All right. So let's start this webinar. Today we'll be talking about migrating applications to open source private cloud. So for those who do not know me, I'm Daniel Virassamy. I'm a principal cloud solutions architect working for Mirantis. Today we have quite a complete agenda around application migration. So it's going to be a mix of slides and demos. We'll be talking about the standard migration strategies, but we'll also look at why OpenStack is definitely a very valid solution and platform for the migration strategy. And then we'll try to change a little bit perspective with Kubernetes. So let's start with the standard 5 R's. We know that you have various ways of creating your applications and see how you want to modernize these applications, right, or migrate them. You have the classic path of rehosting. So this is what we are showing in green here, where you would have your running applications and you would look at where you would want to host these as being the target environment, right? So you would determine a plan of migration. This is common across all these different methods. And then run automation, use migration tools, deploy, validate, and run in production, right? So that's why we showcased on that green line. You have also the re-platform capability. So the re-platform capability is very close to rehost, but in that case, you are readjusting to a new platform. So again, it always starts with the discovery part, building the plan, and then building up the new platform, adjusting the new platform, and then as from there, use the migration tools, validate, and go to production, right? And then the final one is refactor. And refactor, again, we start with the same principles: discover, prioritize, and migrate through a plan. And then there is a lot of work around redesigning the workload, managing the code changes, building all the lifecycle management system around these workloads, doing the proper integration, and then again deploying, validating, and going on production, right? So these are the standard main ways of tackling the migration from a given environment to another environment. And it highly depends on the type of workloads, because depending on some of these workloads, you would be able to, if you have access to the full source code and the investment is worth it, you would go on the yellow path. But for many of the other applications, legacy applications, you don't have the source code, you don't want to invest into that, then in that case, most probably the rehosting or replatform would be the better option, right? But we also must not forget about retaining and retiring, right? So for some of these applications, definitely it would be time to sunset or decommission these, because they would have been replaced by new applications or not used anymore. So it's also a good opportunity out of that discovery phase to decide to remove them from the application portfolio. But some of these you would also not want to invest in any type of migration, whether it is rehost, platform, or refactoring, right? We will just retain them on the current platform. All of these definitely would require strong governance, and this is one of the key layers that you would need to set up around that migration strategy. Governance in terms of then managing the current platform, managing the target platform, building all the processes around that, managing the cost, building the security principles, and then defining the plan, right? So today we'll look at mainly rehost, replatform capabilities, but we'll touch slightly on the refactor part. So let's look at the first approach. You have that VM to VM migration, and here, let's say that you have a couple of platforms that are now available, right? You have the on-prem platforms, mainly VMware and OpenStack. And then you have the public clouds. I mentioned the three major ones: Google, Azure, and Amazon. But you also have Oracle, you also have IBM, you also have Huawei, right? So you have a couple of options out there. And you can see that you have some companies already migrating on-prem to on-prem, like, for example, from VMware to OpenStack, right? Because they don't want to be attached anymore to VMware licenses, and they want to use an open source solution. You have on-prem to public, moving from VMware OpenStack towards Azure, Amazon EC2 instances, or Google Compute, GCP Compute instances. And then you also have the other way around. Now we are also seeing many of organizations deciding to get back to on-prem because of the cost of the public cloud. So it's public to on-prem, right? So you have all these different possibilities. And one of the items that I didn't mention here, you also have public to public, right? So most probably if you have some requirements, cost also, it's all mainly driven by cost. You could move from AWS to Azure, for example, right? If you have some better prices or credits on Azure. So in that case, you have these options of moving around your applications in between these different instances. And each and every time it's quite an investment, right? Because you are not moving 1 or 2 VMs, but you are moving quite a large portfolio of VMs. And this is quite an investment. So how do you make sure that you are selecting the proper solution or the proper platform, and not risking being locked into a given solution or exposed to quite high cost of maintenance of these applications? A couple of weeks ago, we did a webinar. We explained the differences between, and not really the differences, but how you would be able to do the same or cover the same use cases with OpenStack that you are doing with VMware, right? So I linked through the QR code the webinar. So if you want to listen to it at some later time, feel free to do it. But during that webinar, we just explained how you have that capability through OpenStack to deliver an on-premise cloud experience, self-service, with compute capabilities, storage capabilities, networking capabilities, and many of the other advanced services that a cloud would offer, right? And that's all on-prem with a very simple pricing model, where you don't buy per feature, but you buy with a node pricing model, with everything packaged, and you can actually deliver and more services than with VMware, right? And not be attached to the infamous VMware tax. So that's one of the target environments we'll be talking about today, how you would be able to migrate from a given environment to OpenStack, and more precisely from VMware to OpenStack, right? So the migration workload migration process is as follows. You have that governance body, again, which is very, very important. And that governance body will be very closely monitoring all the migration process. And the migration process is basically divided into 2 pieces. The first piece is the preparatory piece, and the second piece is the execution piece. So during the preparatory piece, this is what we call the migration workshop. During that migration workshop, we will be doing 2 major things. The first one is discovery, right? So with the different teams, with the different application stakeholders and owners, we would be going through thorough discovery of the applications in terms of the application portfolio, dependencies, security requirements, scale requirements, backup requirements, whether they are stateful or stateless, and how much data needs to be migrated, right? So there's that full discovery phase, which is done. And then out of that discovery phase, we start to plan, right? We start to plan on which application needs to be migrated with the highest priority, which needs to be migrated with the lowest priorities, how we need to migrate each of these, how we need to manage the different dependencies during the migration, which applications need to be retained or retired, and others to be rehosted or replatformed, right? So this is where we do the planning. So this would typically take 2 weeks to do. And out of that, there is a migrating candidates that are selected, and a report is built, right? Then we come to the execution piece, and the execution piece would take up to 2 weeks or more, right? Depending on the amount of applications that we need to migrate. And this is all automated. So you have CI/CD principles. So Mirantis provide migration pipelines that would, based on that planning, and analysis and design, right? These pipelines would be steered, and then we would run these pipelines to start migrating these applications and validate the target applications, well, the applications that have been migrated on the target platforms, right? So this is how the whole process looks like. And you have then a given platform at the beginning, and then target platform where you have migrated applications. You have two ways of looking at how to handle the source applications. By default, in Mirantis, we don't delete these source applications. We would test the migrated applications first, and then it will remain under the control of the application team to delete the source applications, right? So we don't really roll back at any point, because we know that we always keep that source application, and we always try to go forward, fix things, and until as many applications have been migrated during a given maintenance windows. We have the control of doing it in a parallel manner, whether it is on a project perspective or on an application perspective, right? And that allows us also to do it to increase the cadence of migrating, right? So let's say, for example, we have a portfolio of 1,000 VMs to migrate, then we would be able to run these migration in parallel, based also on the available bandwidth, on the available network bandwidth and storage bandwidth, so that we optimize during a given maintenance window the amount of applications that can be migrated, right? So that's the overview of the migration process. And if we look in a bit more precise manner how we are doing it from VMware to OpenStack, then we will see that we have three main items. The first one is, obviously, we need to prepare the source and target platform, right? And when I say prepare the source and target platform, it's mainly the networking, the bandwidth, right? Network bandwidth and storage bandwidth in between these two platforms, because ultimately it's going to the key factor for migration will be or at least determining the time of migration will be the available bandwidth in terms of networking and storage, right? So the amount of data that we need to copy from one side to the other. So it is a one-to-one copy that we are doing. We are taking VMs from VMware, right? With the format of VMware, so VMX instances, and then we transfer the data, and then we transform that into a volume in OpenStack, right? And out of that volume, then we would attach that to a given instance. Okay, so this is how we would migrate these data. There is no migration or live migration. It's more, you can see it as cold migration, because we are copying and transforming or converting the data or format from one cluster to another cluster, or one platform to another platform. And again, the source is not deleted by default. We would leave that to the application team, and until the target or migrated applications have been tested, right? There is also a matter of driver manipulation. Manipulation when we look at VMware to OpenStack migration, simply because we need to reattach some drivers or manipulate some drivers when it comes to storage, mainly within these virtual machines, right? That's specific to VMware. When we do OpenStack to OpenStack migration, we don't manipulate the VMs, so we don't get into these VMs and manipulate the drivers. In the case of VMware, we need to do that because of the specifics of VMware. In that case, we use libguessfs to do that. We would then install and deinstall specific drivers based on some required storage drivers, right? And then finally, there are concepts that are different between VMware and OpenStack, right? So for example, flavors do not exist in VMware world. Based images do not exist in VMware world, right? Projects or a tenant in OpenStack could relate to folders and clusters in VMware. So in that case, we need to map these different concepts from VMware, what does not exist and exists differently in VMware, to map that into objects and words that OpenStack knows. So networking, configuration, images, copy, project definition, flavor definition, security rules, and SSH keys, and all that. So all of that mapping is also done through our platform, right? So the key to success here is definitely automation. We can't do that manually. We need to reduce the effort. We need to reduce the amount of errors that we can do while doing it manually. And we need to do as many or migrate as many VMs as we can within a given maintenance windows, right? So that's what we want to achieve, because we don't want to maintain the two systems in parallel for a long time. There is a validation through these toolings, which is also important. Can be scripted and also can be done by people. So typically it's a mixed between what can be done with the tool and what can be done also with the staff. We have experience in Mirantis doing that. We have done that multiple times for OpenStack to OpenStack and VMware to OpenStack. And that's how we have built our automated tool. And then, yes, it is for the governance piece. Planning is important. Defining very precisely how we want to migrate the applications, which applications need to be migrated, building that portfolio for the target environment, and having that tight communication between Mirantis and the customer is key. So that in full transparency, the process is managed, right? So now we looked at what would be one of the obvious options, right? So you have VMs on one side, and you would say, okay, why not move that to AWS and put that into EC2, or into Azure, or from VMware to OpenStack, right? So that would be the obvious choice. And the reason that we want to do that is if you are having a go-to public cloud strategy, or you want to optimize your on-prem infrastructure, and you don't want to have high cost of licenses anymore, you see Broadcom acquisition of VMware as being a risk, and you want to go with an open source solution, right? So you have that migration project to set up, and typically the TCO would happen around 2 years, right? So we can do that calculation. But with the reduced cost of the platform with OpenStack plus the cost of migration, typically within the next 2 years, you achieve the return on investment. But we can also look at that with a different eye. And here we want to change a little bit perspective and see why not use Kubernetes as another open source platform, right? We looked at OpenStack as being one of the open source platform, private cloud, a lot of features, self-serviced, and baked with proper security. But Kubernetes can also be a very valid alternative. Okay. With Mirantis, for example, we've been looking at Kubernetes as being the cloud operating system. We have invested in our products, whether it is Mirantis Container Cloud and Mirantis Kubernetes Engine, to be able to deploy Kubernetes clusters in a reliable and generic manner across various environments, right? So you could have Mirantis Kubernetes Engine running on private environments, OpenStack, VMware, bare metal, but also public clouds, Azure, Google Cloud, and AWS, right? And even Equinix Metal. So we invested into that multi-cluster management system. But we also invested into Lens and building Lens so that we could manage not only Mirantis Kubernetes Engine, but all standard Kubernetes and clusters within one single pane of glass, right? So we wanted to enforce through these two or three products, we wanted to enforce that multi-cloud or hybrid cloud approach by using Kubernetes as a single and standard platform across all these different environments, right? And we would then enforce the concept of Kubernetes as being a cloud operating system. And this is very, very key here. And I will explain why This is very key. So if we use that concept of Kubernetes as being a cloud operating system, right, and we would agree that then we would be using Kubernetes on all these instances, then we can start to look at how can we migrate from VM or bare metal instances to containers, right? And for that, we have a platform which we call Mirantis Application Migration and Modernization platform, right? So I explained earlier our platform for VM to VM, so typically VMware to OpenStack. And now this is a second platform that we provide, which now allows us to migrate from virtual machines or bare metal, right? Services running in these legacy platforms, VM or bare metal, and move them into modern application platforms where you can run containers, right? We can run this on any infrastructure, right? Again, we enforce the same concept. If you remember, I said Kubernetes across all these different environments, and Kubernetes as being the cloud operating system, right? To avoid any lock-in into any of the proprietary closed source solutions, whether it is private or public clouds, any infrastructure. And on these infrastructures, you can then run any Kubernetes clusters, whether it is Mirantis Kubernetes cluster, whether it is Tanzu, whether it is OpenShift, whether it is EKS, AKS, or vanilla Kubernetes, right? And AMMP, so Application Migration and Modernization Platform, would work in a very specific mode to allow you to discover, transform, and deliver your applications, right? So I'll explain in more details how that works and do some demos of that platform for the rest of the webinar. So how the application migration platform works then? We would look at that with 6 big steps. The first one is the assessment, right? And this is a key stage. Very similarly to whether when I explain the 5 R's or whether when I explain the platform we are using for VM to VMware migration, we always have that step of assessment. And that step of assessment is key because this is where we would discover and analyze the application portfolio, right? So this is an automated process by default in the application, but you can also import within the platform your database of application portfolio that you are maintaining, right? So you have these 2 modes. Either you import your application portfolio, or you allow the tool to assess and discover these applications, right? So workload analysis is a first step, and then once we have detected the different processors or runtime, we can then do a deep dive within these processors and runtime to go and detect specifically applications, right? So this is what the tool technology that the tool use is X-ray. Not to look at X-ray from AWS. This is a completely different process. Here it is AMMP X-ray, right? So we would be taking the processors, and then we will analyze these applications, right? Then the next stage is the plan or rationalization. And the plan is basically whether, again, we need to define which applications will be migrated with priority or less priority using rehost process, refactor process, or replatform process, or ultimately retire these applications and retain these applications, right? And this rationalization is based on recommendations. So out of that assessment, an intelligent recommendation is made, right? So it's all part of the tool. It's automated again. And an intelligent recommendation is made based on the analysis of these platforms, of these applications, sorry, right? So this is where we would provide these recommendations. And out of that, then, we would start to define the rehost strategy, the replatform strategy, and the refactor strategy. Once this is all done, then we move towards the continuous integration and continuous deployment or delivery platform, right? So in that case, what we need to do is we need to take these applications and we need to transform these applications. We need to transform, which means that we need to take these applications from VMs and we need to put them in containers, right? So that's one of the first steps. Then we would need to build the blueprints for these containers. And what I mean by blueprints is the definition or the template that would define how these containers need to be deployed in a target Kubernetes cluster. And that target Kubernetes cluster can be anywhere. Again, we are agnostic, so it can be on-prem, off-prem, in public cloud, and any of these Kubernetes clusters, right? And this blueprint would be the source of truth of how to deploy these applications. Then you have that deployment phase where we would be running these blueprints to deploy into Kubernetes clusters, and finally we would iterate to improve these applications, right? So we would build, blueprint, and deploy on the first iteration. And then on the second iteration, we would readapt, modify these applications, already containerized applications, but we will improve these applications, right, with new versions, new updates of the binaries, rebuild the containers, update the containers, and until we are on the proper target, right? Okay, so let me pause here and show you how that works through our platform. So this is Mirantis application modernization and migration platform, right? So we have the capability to deploy this component in an organization premise, or we can also host that in Mirantis premise and then connect that to your target environments, your source environments and your target environments, right? As long as we have access and we are able to secure VPN access, we are able to do that. We are able to host this application in public cloud. We are also able to host these applications on your environment. Okay. So the first thing that I said we would be doing is we would discover. We would be discovering applications, right? So to do discover, then I go on this discover tab. Here you can see that I have the notion of waves, and I'll explain a little bit what we mean by waves, right? So here I have two waves. I'm going to look at that wave, which is mine. And within that wave, you have the capability to add source host, right? So to add a source host, whether it is a virtual machine or a physical machine, you would basically just click on add host, give a name, right? Test virtual machine, give the SSH access with a given credential, so public key, for example, or user password, right? So you would be creating these secrets in the vault. Give the default username and the IP address, and that's the only thing that you need to do to create this machine, right? You can also see that here on the host, you can also upload your discovery data. That's what I was explaining. So either you already have a database of applications that are running in your different machines, or you want to let the platform discover it for you. Okay. So in this wave here, I already added a virtual machine, right? You would notice that I'm not deploying any agent in these virtual machines. The only thing that I need is an SSH, a valid SSH access towards that host. And as from there, the platform will be able to go and discover applications within that. To discover applications, what you will be doing is first you will check the connection, right? So you will click on this button, and you will just then check whether you are able to connect to that machine. And yes, here you can see that it's green status. Then the second step is you will be doing the check prerequisites, right? And some of these prerequisites is do I have proper privileges within this this machine, right? Am I in the sudo group, for example, right? So these are some of the pre-checks that will be done by the platform. And finally, you have the discover button. So you would click on discover here, and the platform will start to look into your system, right? And discover the application. So here, if we click on view log, you will see that it's connecting to the machine, and then the system collection or the collection of the system information is in progress, right? So as it's doing the discovery phase, then once that status is green, you will then be able to discover through that component tab the different applications that have been discovered automatically by the tool, right? So here you can see that it's green, it has discovered everything. If you click on the machine, we'll also have the white list the white list of applications that can be discovered or not discovered, right? So you would see here that for example, I'm excluding all the systemd or the auditd, crond services, and I'm only allowing the services here, right? So you can also manipulate which services you want the tool to discover or not discover, depending on the application that you're running in these virtual machines. So in components here, you can see that the application or the tool detected 3 applications. It detected an application running in Tomcat, it detected an application running in Apache, and it detected an application running in MySQL, right? And actually, for that given machine here, I have these applications that are running. So you can see it's 15178. So I have actually I have a Tomcat application here, which is called my app. I have another Tomcat application, which is called sample. And I have a WordPress, which is also running on that virtual machine. And this is why the tool discovered the Tomcat applications and the WordPress application running in Apache and MySQL, right? So what now you want to do is to analyze in more details these services, right? So as I explained here, first step is workload analysis, and now you want to get into more details with X-ray. So to do this, you would then select the process. So let's say I want to now analyze WordPress in Apache 2. I will just click on X-ray, right? And what will happen is that the X-ray will start on this application. And after some time, I will have a button that says you can stop X-ray, meaning that I have discovered the applications, right? So I already did it on Tomcat here, just for the sake of time. And that application has been discovered. And you can see that I have a button that says I can containerize it, right? But before I'm going to containerize that application, let's look at the intelligent report. So I say that I have intelligent reports that are built that then give me recommendations in terms of whether I need to rehost, replatform, or refactor these binaries, or even retire or retain these binaries, right? So then how would that look like? Is I would go to report, and in report, you can see that I can generate CIO reports or more technical reports, right? So let's directly go to the technical report. And in this, you can see that, yes, I have one distribution, right? One Linux, I only have one host. But you can imagine that when you have tens, hundreds of virtual machines, right? So you can define a wave, and a wave is basically a way of handling the resources and the strategy of migration. So you would group within a wave a group of virtual machines that you would be analyzing and then defining a strategy to migrate. So in this case, I have only one host. You would have the intelligent recommendation on whether you need to retire, retain, or reinvest. And here you can see that, yes, it's telling me to reinvest, right, and not to retain or retire these applications. So this is a good thing. Then directly I can know that, yeah, I need to spend time, and it's worth spending time to migrate these applications. through past experience of our of Mirantis and our platform, and based on the application properties, right? And we would also then understand whether it is Linux applications, Windows applications running on AIX applications, what type of application services are running here. So you can see here that it detected one Java application, which is running in Tomcat, MySQL here, and one unknown, simply because it's still doing the X-ray on the other side, right? I have a map of the applications here that I can see, right? It's a little bit small, but I can increase it. But you can see that you have Java, MySQL, and web front application. These are still being analyzed. Yeah, and out of that, I can then download that PDF. So this one is a little bit simple. I can show you a more complex report in the deck, but this one is definitely simple because I only have one very simple application, right? So now that I have that rationalized application, what I want to do is start to have that transformation blueprint deploy cycle going on, right? So to do this, then what I need to do is I need to prepare my platform a little bit. I need to prepare 3 things on my platform. I first need to define a build box. And what is a build box? Basically, this is a box running Docker engine, so Mirantis container runtime in this case. And with Mirantis container runtime, we can then build and sign images, right? So a build box is simply an instance, a virtual machine that would run somewhere in your infrastructure or environment, in which we are installing Mirantis container runtime as being the container runtime to build the images. The second thing that I need to do is to add a container registry, right? So here I added 2 registries. I added Mirantis Secure Registry, MSR. And I also added a Docker IO registry, right? And so I basically need to add the target registry where I'm going to save my image. And then the last item that I need to add is a cluster. So here you can bring your own cluster. So bring your own cluster here. You put the name of your cluster. You indicate which cluster you are using, whether it is an EKS cluster, AKS cluster, GKE, OpenShift. Bring your own cluster, Kubernetes cluster, Mirantis clusters, right? You can select the cluster that you are supporting, and then you just add your kubeconfig file, right? So here I already added a cluster here, which is a Mirantis Kubernetes engine, which you can see here in Lens. So Lens is a UI to manipulate Kubernetes clusters, and I'm basically running Mirantis Kubernetes engine on 3 nodes here, right? 1 master and two worker nodes. Okay. Once I have done this, then I can start the transformation of my application. So to do the transformation of my application, I select the wave again. In the wave, there is one application which has been discovered by X-Ray, which is ready to be containerized. So I will select this application. And actually, this is these applications, right? The sample application here or the Hello World application here. So I'm going to containerize these applications. And to containerize these, what happened? By the tool will automatically build the Docker file for you, right? So basically, this is what you will be saving then, because this will be the blueprint of how you are going to build your application, right? And this is also one of the magic of this platform is you don't need to write the Docker file. It has discovered your application, and it allows you then to automatically create these Docker files. And if you remember then, if you are going to use that iterative process, this is how the build and rebuild will happen, right? Because you will be, again, amending that Docker file with newer versions of the base image, with newer versions of libraries and all that, right? So you have that Docker file. You can select specific files from the source, right? Because it analyzed the source image, and it gives you more flexibility on which files you want to import or which files you don't want to import into the container image. You have the ability to also define some specific container config, like the amount of CPU, replica, that needs to be deployed, network and volumes that you want to do, right? But here we'll just build the image. So to build that image, we will start to use some of the artifacts that we have used or we have defined in the platform. So the first artifact is the build box, right? Because I need to take the image from virtual machines and I need to build them into containers. So let me just select the build box. The second thing is I now need to select the registry. So let me use the Docker IO registry, right? And I have already created a repository, which is an empty repository, right? You can see it's completely empty. And I've called it CamuDV web front. So let me just copy that that repository here, okay? And let me give it a tag. So let me, for example, latest, right? And as from there, I can build the image. So I'm going to build that image from the actually the this Docker file definition, right? So now I need to wait for the image to be ready, containerization in progress. And once that image is ready, I will then see this image being populated in my repository, right? And you already see that that image is already being pushed, right? Now, the first version, the first image is pushed, and the second image will be pushed with the latest tag, right? As it's doing this, let me continue a bit on the presentation and talk about the application compatibility, right? Because here I talked about Java applications, but when you look at what cases we support with this tool, you will see that we support the three major operating systems, so Linux operating system, Windows, and AIX, right? And various versions of Linux. So Red Hat Enterprise, CentOS, SUSE, Ubuntu. As long as we have SSH access, we have that capability to integrate. And it's also a tool that we are handling and managing. So we have that capability also to modify and adapt it to the source Linux distribution, right? The same for Windows. We depend on the way that we can authenticate with Windows. So 2008 version, 2012 R2, 16, 19, and even 2022 are things that we would be able to support, right? And then in terms of application, then we would be using the various application stack. So Java middleware stacks, definitely, whether it is WebSphere, JBoss, Tomcat. So here, in the example I showed, I'm using a Tomcat 9 platform, Windows stack with .NET Core, IaaS servers, Java applications, and other stacks like Node.js, Nginx, Ruby, C and C++, binaries, right? So all of these are supported. And then for database, it's a little bit specific, and this is typically a little bit more complex for these specific applications. And as from there, you would see that we have that support. And then for the databases, we would be doing it through services, right? Because it's not directly managed by application modernization, but we typically attach services because it's handling data, sensitive data, and each of these databases have very, very specific way of handling their way of integrating and doing data migration, right? Important thing here is we don't need the source code of the application. As I explained and I showed during the demo, when I connected to the virtual machine, discovered the Tomcat 9 application, and started to X-ray into that, at no point I connected to a source repository. So I don't need to have the source code. The way that we are doing it is we are analyzing these applications, we discover these applications, and then we migrate them, we unpack them, we take them from virtual machines, and we put them into containers, right? This is then based on the intelligent report. This is how we would be building a complete assessment map, right? So we would say, okay, we have clustered applications, we have standalone applications, we have stateful applications, and we have stateless applications. And based on the combination of clustered, non-clustered, stateful, and stateless, we know that standalone stateless are definitely easier applications to migrate. And stateful clustered applications are definitely harder applications to migrate, to manage, right, or to migrate. And our recommendation is always to go with at least a couple of easy applications first, so that you understand the migration concept, right? So it's like having or setting the proper foot. and just doing it a couple of times on some of these easy applications, and again understanding the mechanics, right? And as from there, you can then decide whether you want to do clustered stateless or then standalone stateful, and then ultimately do the hardest applications, which again, these are mainly database services and message queue services. This is where typically you would then be doing it at the end, right? Here is a more detailed report where you can see in more details the applications with libraries that we have detected, dependencies that we have detected. And we know that based on these dependencies, these are the dependencies that we'll need to package into the container image, right? And out of that, then we have these criteria, discovered information, recommendation, and then effort of migration, right? So we rate all this. And based on this rating, then this is how we would say, okay, it's worth investing or it's not worth investing into migrating these applications, right? By that time, let me switch back to the platform. We must now have the containerized application. So yes, you can see that Tomcat has now the application which is ready. If I move to the repository, you would see that the container is just here with the tag latest, right? So let's see how I can use now this application. What I will now be doing is I need to build that application, right? So I transformed it. I now need to build a blueprint and then deploy that application. So let's go and build a blueprint. So I'm now going to create a blueprint. I'm going to name it, let's say, web front. I'm going to indicate which namespace, Kubernetes namespace, I want to deploy it into. It's web front. Let's give it a name, AMMP demo, right? And then create blueprint. And within that blueprint, I'm going to create a deployment object. So I'm going to call it web front. So this is a Kubernetes deployment object, and add the container references, right, in it. So so as this is a Docker IO, so I only need to give the repository namespace and repository. Right, give it the tag. So I have the latest tag and then the port on which it is listening. So it's 8080, right? I can give other configuration if required, some configuration for config maps, the secrets, PVCs to define, liveness probe. So I can define all this within that page, right? Let's keep it simple. I created that blueprint now. It is ready to be deployed. So what I will be doing now is go back to my blueprint, click on this, and I can here create the workload. So to create the workload, I can select the environment in which I want to deploy it. So I can tag the target environment, whether it is a development environment, QA, staging, or production environment. So let's keep it development, name it test. Let's select the cluster. So if you remember, I showed that we created a target Kubernetes cluster. So it's a Mirantis Kubernetes engine cluster. I want to keep it in the namespace that I define in the blueprint. I want to attach it to the ingress that is available in the cluster. And then I'm just going to validate that. All right. Now it detected that the application is ready to be deployed. It detected my cluster. It detected that I have 3 nodes, right? If you remember here, you saw that for that given cluster, I have 3 nodes, 1 master, 2 workers. So let me just select the proper node. Let me select this one, for example. It is a Linux node. If it was Windows, it would have detected a Windows node. Click next, and then as from there, I can start deploying, right? So now application deployment is pending. If I go to my cluster, right, go to pods, I can now see that there is a web front namespace that has been created, and the web front application is now being created. It's in pending mode. Container is being downloaded on that compute node, and then once ready, the application will be in the proper status, right? So I just need now to wait for it to be running. let's wait a little bit. As we wait for the application to be ready in the Kubernetes cluster, let me continue a little bit on the presentation because of time. So let's look at how that would apply to a whole organization, right? I want to scale out that strategy because in the demo, I only showed one application, migrating that application, containerizing that application, and then deploying it using a blueprint. But how do we manage that in a large organization? And this is where the wave concept is important, right? So you can have a whole data center, and within that, you have multiple application owners, right? And within these application owners, you will be defining your waves. So let's say you have wave set 1 up to wave set 5, right? And within these wave sets, you then define these waves. And within these waves, you will have your group of VMs or group of bare metal servers, or a mix of VMs and bare metal servers, right? So this is how you would logically segment the source applications and source VMs from your current environment, source environment, and put these into logical blocks that we call waves. And within these waves, then you start to migrate your applications, right? Definitely, if you want to see that in action, this is an example of one of the projects we realized in 2022. That customer had 700 applications to migrate, and you can see some of the metrics here, right? So we took 3 months to assess these applications. And from these 3 months, we started to migrate and containerize these applications, and it took us around 6 months to do that. And in parallel, we started to deploy and prepare the target environment. And within the next 4 months, we migrated these applications, right? So it took us about 10 months in total to migrate 700 applications from a generic legacy platform towards a modern Kubernetes platform, right? And if you look at the amount of time that we saved during that, we can count that as around 20,000 human hours saved doing it manually, right? Because the way that the tool automates all the process, it saved a lot of time for people, right? It also improved the way that these applications are being deployed on these environments. So we achieved 600% efficiency in terms of deployment for these applications, right? So these are some of the KPIs that we can share. We have other examples where we can share also the amount of applications, the time that it took us to migrate these, but that's the value of that tool. It's providing time to your team to concentrate on the most important items, which is after doing the migration, to continue the development of these applications and to keep doing the innovation within these applications. And let's say we want to go a step further, but in this case here, we looked at containerized applications, right? So we had these processors, application 1, application 2, we had a couple of processors, we identified these, and then we transformed these, right? And that's what we did. We containerized these applications, and then we deploy these applications. But then you can start to go a step further, and that step further is refactoring. And what I mean by refactoring is then you can just start to break down these applications and start to build microservices around these applications, right? So to move them from monolithic applications into microservice applications. And you can do that in multiple steps. And this is where refactor is key, right? And if you look at the tooling and how it complements the existing tooling of step 1, 2, 3, 4, up to 8, then you also have that CI/CD pipeline which comes in. And that CI/CD pipeline is there to take the asset that the tool built, and from that asset, you have that ability to continue building on top of that Docker file, update the libraries, break out into microservices, build more and more complex Helm charts, and automate all that in the CI/CD pipeline, right? And have that as a repeatable item. Before I move to the summary, let me go back to the demo environment. So here, most probably the application is now up and running. So we can see it up and running, right? And that application, unfortunately, I didn't define any service for that given application. So let's just build a service for that given application, right? And that's one of the cool tricks about Lens, is that I can directly create a resource file here. Just select a service file, right? And within that service file, I'm going to do some amendment. So I want to name that service web front. I want to run it in the web front namespace. I want also to type that service as being node port, okay? And as from there, I want to change a little bit these port targets to put it as being, for example, 35,000 targeting to 8080, right? So here I'm defining that very simple service. Okay, then create and close. Right, the service is running now. I have exposed my service. So how will that work then? So let's just look at on which node that application is running, because I used a node port. I didn't use a load balancer type service. I know that application is running in that node. Again, that's one of the powerful features of Lens. It's so easy to just go through these different interfaces and access the services. So let's look at the summary then. So what did we look today? We looked at the ability to migrate applications from a given platform, typically closed source platform, VMware, or even the public clouds, and move that to pure public cloud, open source platforms, right? We look at the first option as being towards OpenStack, as being the open source private cloud offering. Another option would be Kubernetes as being the open source containerized offering, right? But the target environment at the end of the day, if you look at the different strategies, whether it is VMs to VMs or VMs to containers, most probably it's going to be a mix of both, right? Because if you are going to retain some of these applications, maybe you don't want to retain these on expensive proprietary closed source platforms. You would want to invest into standard open source platforms like OpenStack, right? So the ideal target platform would most probably look like using OpenStack as being the underlying infrastructure, running open source distributions like Linux distributions as VMs, and then on top of these VMs run Kubernetes, right? In that case, you have a complete, secure, and fully open source solution on the infrastructure level, on the operating system level for virtual machines, and on the containerization level, right? And the benefits of it is you have the reversibility of your applications. You are not locked in at any point. Kubernetes is the cloud operating system. Wherever you're going to run Kubernetes, you have that guarantee of reversibility. If I'm going to deploy my application on EKS, I know that I can deploy exactly the same way that application on Mirantis Kubernetes engine running in that given setup, right? The second benefit is the control of cost. As you are not locked in, you are not going to get the bill shock, right? So ultimately, if you do receive that bill shock, because you are running expensive services on public cloud, you have that ability to take back your services and put them into your own premise where you are controlling your cost, and you are optimizing the environment with complete, secured, and fully open source platforms, right? So how does Mirantis help in this ecosystem? We have what we call the zero ops approach, and that zero ops approach is here to allow organizations to concentrate on innovation and applications, right? So typically what we would say is you would be doing the apps and we would be doing the ops. So there is the concept of no lock-in, use open source solutions, which guarantees reversibility and cost control. We saw that in the previous slide. And there is also that element of trust, right? To work with a trusted partner. And we as Mirantis, we are that trusted partner with a complete portfolio of offerings. We can help you build platforms, whether it is infrastructure platforms, containerization platforms, and do it in a way that you concentrate on your apps and we do the ops. But we also have that application modernization offerings, where today we showed our capability to migrate from VM to VM, VMware to OpenStack, and also from VM or bare metal to containerization platforms with application modernization and migration platform, right? So we have that full offering. So thank you very much for your time today. I hope it was useful for you. Sorry for any inconvenience. Feel free to reach out. Happy to run again this session with you if required. And looking forward for the next session with you.